Hi, Chris. This is Steve here. So I was reading your blog about your students' discovery about the quadratic here, and it made me think of something interesting. So here we've got the parabola y equal x squared, and there's that specific point 1 comma 1. And I really liked what your student did about observing that if you just vary the b, then you could adjust things so that it always went through that point. And by keeping the sort of same, quote, steepness of the parabola, you made kind of a parallel thing. So let me do what your student did here. Then all these parabolas are going to intersect at a nice unique point at 1 comma 1. And if you'll notice, there's kind of a pattern developing here. Sort of an interesting turnaround point happens right there when it hits that green dot. So how can we describe that kind of interesting change that's going on there? Well, let me just highlight the vertex point for a minute. So I've highlighted the vertex point right there. So, and you'll notice, as I kind of vary this, it traces out a path. Well, what is that path? Well, let's highlight that path for a second and see what's going on. And voila. So the blue thing is the path that the vertex of all these parabolas make in that system. And lo and behold, that appears to be another parabola. And in fact, if you explore it a bit, you can actually show algebraically that indeed the locus of vertices of all these parabolas in this equation do in fact trace out a parabola. And they might want to explore the properties there a little bit. And I think the graph sort of makes you think of some interesting properties of this. But you can actually take it a bit further as well. Let me put it back to the way it was and turn off this locus for a bit. So you might want to say, I wonder what would happen if instead of adjusting the b, adjusting the a. Now, here it kind of loses, it's starting to move away a little bit from your original question about having exactly one solution. But watch what happens if we decide to change the a instead of the b. So still always going through that point 1 comma 1. And if we trace the vertex, it's like, okay, not super interesting. It's just moving up and down on the y-axis since we never changed the b. But here's an interesting question. What if we, so right now the b is just set at 0. But what if we change the b a little bit? So maybe choose this b right over here. So if I were to choose that b, and then move the a's, that vertex seems to be doing something a little bit different. So why don't we take a look at that trace and see what's going on. Boom. Hold the phone. That's not a parabola anymore. That's some sort of other shape. Well, students could explore, what does this other shape appear to be? So, I mean, to my eye, it kind of looks like some sort of tilted hyperbola. So if they've seen conic sections, which probably at this point, if they're in their Algebra 2 class, they have not seen hyperbolas. And then there's other interesting questions like, well, how does this hyperbola, if indeed that's what it is, change if we start changing that b? But anyway, just interesting things to explore, so I just thought I would show you that really fast. That's it. I hope your Algebra 2 class is going great.